Welcome to the feedback from the Unit 8 quizzes that you've done. So the quiz for 8.1, the periodic table, was generally well answered, so well done on that. And there's no need for me to go over any of the questions. For 8.2, the periodic table, a few of you struggled with the answer to the question, why does silicon have a very high melting point? So the correct answer is that silicon is a giant covalent structure, and therefore there are many strong covalent bonds that need breaking. So most of you got this answer. So if we look at the breakdown of the questions, 19 people managed to get the correct answer, but a couple of people talked about that it's a large molecule, so there's many van der Waals forces. So what you've got to remember is that van der Waals forces are between molecules. So that's only for simple covalent compounds, because in a giant covalent, there's only one molecule, because it's all one big, massive molecule. And therefore, you can't have van der Waals forces, because all you've got is covalent bonds between the atoms. And one of you talked about giant ionic lattice. So an ionic lattice has to be in an ionic compound, and silicon is an element, so it can't have ionic bonding. The rest of the questions on 8.2 were okay. So on 8.3, the question that most people had trouble with was, what factors are responsible for the trend in atomic radii across period 3? So there's two correct answers for this. There's the fact that as you go across period 3, you have an increase in nuclear charge. And as you go across period 3, there is a stronger attraction between the outer electron and the positive nucleus as a result of that increasing nuclear charge. So in terms of breakdown of your answers, only just under half of you answered this question correctly. Most of you got at least, in fact, all of you got at least one of the correct answers. It's just that some of you had put that there was more outer shell electrons. So as you go across period 3, there are indeed more outer shell electrons, but that doesn't have any bearing on the attraction between them and the nucleus. So if you put that as one of your answers, then you automatically got it wrong, even if the other one was correct. And more of you put the increasing nuclear charge, but some of you put that just by itself, and some of you put the stronger attraction between the outer electron and positive nucleus just by itself. So 8.4, it was excellent answers, 100% apart from question 4. So well done on that. Question 4 was, what is the trend for successive ionization energies of an atom? 89% of you got this right. So it increases. So whenever you, so successive ionization energies is when you take, so you removed one electron to become +1, and then the next one is +2. So you've removed another electron, and then you remove another one to do +3, etc. So that's always going to increase, no matter what the atom, no matter what the element is. And most, as you can see, most of you got that right. So 17 people got it right. Only 2 people said decreases. And sometimes you need to explain in an exam why it increases, and that's because when you are removing an electron from an already positive ion, then because it's already positive, you're trying to remove something negative from something that's positive. So as it becomes increasingly more positive, it's going to be more difficult to remove that electron because of the increasing positive charge. Okay, thank you for listening. Good luck on the next quiz.